This is a review of the Yahboom Tank bot, G1 smart robot from the perspective of a programmer that you might want to use this for 360 video camera work. So I'm going to eventually attach this thing to a RICOH THETA Z1 to do object detection and other things, as well as a RICOH THETA V. And I'll evaluate it from that perspective. So this robot's quite good. The metal, it's a 3mm aluminum, so this should be a fairly good base for the Theta. Got the motors installed already. It looks quite good. Started to assemble the rechargeable battery pack that does come with the camera. Also ultrasonics. There's a separate I did buy the Raspberry Pi model of this. So it does have a separate camera module which will go on this, but eventually it will take it off and then put the Theta on. One thing is that it does use the Raspberry Pi 3 or Raspberry Pi 4 that does not come with the kit, so you need to buy this separately. I did look at ones for the Jetson Nano, since this has a better graphics hardware acceleration capability for streaming or processing 4K video, which both of the cameras that I will be using, it does do 4K. So, but I think I could either use the Raspberry Pi 4 at 2K or put the Nano, which would be better, obviously. Maybe I'll somehow mount it and then put the, maybe I'll mount it here, right? And then put the camera on it. What I'm eventually going to do is use the Raspberry Pi as the controller for the robot to handle the motions, and I may also control the camera from the Raspberry Pi. The Raspberry Pi does not come with the kit again. The camera also, this camera does not come with the kit. But it does come with some pretty good electronics. So it does come with the controller board to control the servos and the motors of the robot. It looks fairly good build quality here. And then I have a Jetson Nano on the back of the camera here. Which I'll probably use the Nano to control the camera, although it does work off of the Raspberry Pi 4. So let's take a look at some of the other software that's being used to power the robot. First, I'll give you a few tips about the hardware build. The parts aren't labeled in this kit, so it's not that easy to assemble. I recommend you get a digital caliper here like this, or a ruler, and just be pretty accurate on measuring the diameter of the different spacers in the bolts. So I got this from Harbor Freight. It's pretty cheap. I think it may be under, like, I don't know, maybe 10 bucks or something, you can get it. So that's one tip. Another tip is, although they do give you this little screwdriver here, which is actually pretty good, it's free. You're going to want to get another screwdriver with a different head here, like a smaller one, because that yellow one's just not going to cut it for all of the screws, and you may strip the heads. Also, to hold some of the parts, you might want to get a forceps like this. This one's actually for fishing, so when you're done with the build, you can go fishing, right? So if you have these type of forceps like this, you don't have to hold it with your hand, otherwise it's pretty difficult to grip it. The kit does come with a rechargeable power supply, plus the actual wall charger to charge it. So the kit is pretty complete except for the Raspberry Pi. And if you want to put external attachments onto it, like I'm planning to do, this particular camera is like $1,000. So I'll probably use the cheaper one, the Theta V, but that's still about, I don't know, $350 or something. So if you want to do 360 degree imagery or video, that's a whole different ballpark. But I just got this kit as a base. I don't have to construct the metal pieces myself. And also there's a base for the control of the robot. I currently have the RICOH THETA Z1 connected to the Jetson Nano. I have the Jetson Nano attached onto the top portion of the robot. And the Z1 is live streaming a video feed in 360 degrees to the Nano. Right now the screen is in a rectangular mode, but as you can see I have object detection enabled on the 360 degree. So you may not be able to tell, but it has the accuracy of the person on it. So at this point I'm 90% a human being. Further away it's going to track me. So while this is pretty common on normal webcams, right? You can get it to work. It's a little bit more tricky with a 360 degree camera that's live streaming the video feed from it. So on the robot, this is not going to be the final mount here, but I have it actually attached to the monitor so you can see it, but it will eventually just stream out to another device for processing. And I've had some more mounting hardware for the camera so that it's a more stable mount there. The part I wanted to show you is that the objective is to get this object detection working for the full thing. So this camera doesn't rotate. If you have a normal robot, it's going to have to rotate this section here. But because it's a 360 degree camera, the robot can just go and see the entire world, up, down, everything. Like I have my hand right above it, and it's still going to be able to see everything around it. So let's dig more into the software and see what we got here. About the detection here is that I did mention the camera is streaming 4K, but I'm using a DetectNet deep learning, and it's actually was having a problem at 4K processing with a DetectNet deep learning. It's NVIDIA Jetson, so I'm using the CUDA cores on it for GPU processing. I did have to cut the video feed from this down to 2K. I might upgrade to the Xavier. It's more cache, but if you're going to production, you probably want to do at least the Xavier, because or you can just live with a 2K. This is just for prototyping, so I will just keep the Nano because it's cheap. There's other ways to do object detection too, but this one is it's a deep learning network for this one. Yahboom Tank does not come with these components. It does not come with the camera. It does not come with the Jetson Nano. It does not come with the DetectNet, although DetectNet is free software. You can just download it and you're good to go. What we're evaluating here is the applicability of the robot to serve as a base for other types of deep neural network learning projects. In particular, being able to transmit the video feed from the Jetson Nano over some type of IP network over to another device. What we're looking at is just the evaluation of the robot, but because my project is a little unique, I did want to give you some additional context for the review. So I just took a picture with over the USB cable using ptpcam. I did a modification of it on this repo here. But you can get the code also from SourceForge for libptp. The image that's being flashed on the Raspberry Pi that will go into the tank is Raspbian 10 Buster. This is the Yahboom site for the tank. It's a robot that we're using. And there's quite an extensive set of information here on how to use the Raspberry Pi, how to charge it. So you can also go to this site, yahboom.net, right, and then to see what they have for the software. The Raspberry Pi image, I got it from here. So it should serve as a base for their applications that you would need to install on the robot. I'll probably install it initially just to make sure everything's working, the hardware parts are working. As I mentioned, I'll probably actually use the Theta with Jetson Nano so I can get the streaming working and then transmit it to another computer or some type of headset to experiment with it. But I may, as an option, you could, if you just had one board, so if you don't have a Jetson Nano, you can start using the Raspberry Pi that you will need for the tank anyway, which is the controller. It appears you can use it, I'm assuming, I haven't tried it yet when it's plugged in, but to actually control the Theta as well, to at least take pictures and maybe send it off to another cloud-based site. With a fair bit of configuration I had to do to get the Raspberry Pi image to work with the Theta. It's a standard Raspbian image, but I think they did configure it a little bit. So I had to install a bunch of other libraries for that, which we've documented on our site. The purpose of the initial test was just to see whether it was standard Raspbian or whether it was something different. It appears to be standard Raspbian running Linux, so we can use all of our tools that we normally use for the Theta, including ptp, libptp, and libusb. So it's looking fairly good right now for the software components that we would need. Now I have the THETA Z1. It's on a small tripod, but just wanted to review a couple points about the mount here, since I'm going to mount on a robot. So that's just a normal 1/4 inch by 20 thread per inch stud right there. I've ordered some bolts off of Amazon with washers, so I'll probably use that to bolt it directly onto the top part of the robot. The other thing is this camera, the Z1, has a USB 3.0, USB Type-C, using USB 3.0 specifications, so it can be powered indefinitely, and I can control the power on, power off, sleep, wake, and change the mode of the camera over the USB cable. So that was the purpose of this portion of the software test. Just a close-up of the control module that is going to attach to the server. It looks pretty well made. Just a quick point about some of these pins here. This pin cable at the bottom, this pin row here, is going to plug directly into a pin cable, which then goes on to the Raspberry Pi, right? So it's I have some other wires here right now, but so this row, this header row, will go onto this. There's a cable that comes with it. These are unused as far as I can tell. I think this one's for a different board. This one's for an Arduino, I think. And then, so it has the pin connectors for the servos and other things. So it looks pretty good. People have some stuff to say with the documentation. It's all there, and there's some videos also online to help you with the assembly, right? But pretty small print and lots of pictures, which are accurate as far as I can tell. I haven't run into any problems yet, but there's a lot of parts here. So this is good enough, I think, but it's good enough for me. But I can understand that some people might have some issues with the documentation. So there's two things. One is it detailed enough? Eventually, I think you can do it. One of the problems is making sure that you have the right screw. The screws are not labeled in the package, so you're going to have to measure the screws. That's why I was suggesting a digital caliper. So just to let you know that the parts are there, but they're not labeled for the most part. They have a nice video online which you could use. There's a couple more tricks here. It's another tip. The documentation on the paper is a little hard to read, but they do have this online documentation on the Yahboom site. So if you go to instruction manual here, you can download a RAW compressed file, and then you can see it on your computer. So it's probably better if you use Windows, because I actually had a bit of an issue trying to open up the RAW file on Raspbian, which is right here. Okay, so one of the challenges with this type of project is that some of these screws look very similar, but they're actually not the same, right? So this is 2 mil by 10 mil. So you have to make sure that when you're following the video online, and that's the way to make it, right, is that you actually are using the correct screw, M2, 2 mil by 6 mil, right? And there's many of these columns, these pillars. Some of them are pretty obvious as to which one is which, but this M3 times 8, there's a lot of these screws, right? So this is 3 mil. If you have a digital caliper, you could easily measure the diameter of the pin. They have both pages, so this front and back, right? So it starts out very small, and then you keep increasing it until you get the visibility that you want, so that you can actually then figure out and work on that section. Without this type of technique, you either need a young person with very good eyes, which you could be young, or you're just kind of guessing and squinting a lot. Part of their image is that they have a fair bit of programming tools for your learning. So this would be quite good if you are interested in programming. I think if you're interested in programming, this is a good kit for you. These tracks are plastic, they're not rubber, so not sure how much grip they would have on a smooth surface. It does have these ribs, so it should be fine, but they're not rubber. Also, when you're assembling it, make sure that these pins are aligned. Although the disc looks like you can flip it back and forth, this gear, you can't. So if they're not aligned, take it apart again, this gear in here, and flip it around. I'm quite happy with the robot. I think the build quality is great. I'm probably getting it as a parts type of kit, and then I'm going to put my own software into the robot. In particular, I'm trying to use the camera, or RICOH THETA Z1 in this case, connected to a Jetson Nano, which is not actually, the Nano is not actually going to control the robot. I'm going to use the Raspberry Pi to control it. And so for that purpose, it's good. I think that if you want to learn to program, or you're buying it for parts, I think the kit is great. I haven't evaluated it if you just want to build something quickly and use it, and then you're good to go. So I can't really comment on other uses of the the robot. The build quality is good. The electronics seem good. They seem to be functional. Everything appears to be there. All the parts are there. Shipping was fast. Quite good things to say about it. However, my use case is a little different probably from most people. So just keep that in mind. Once I finish the build, and I'll update the video.